Okay, so the last two topics we need to cover for this section is dealing with linear equations and scatter plots. Okay, so um, we have a set of questions here, and before we answer these set of questions, let's talk a little bit about two terms. Okay, they are independent versus dependent. Okay, so in linear algebra, all right, or linear equations, I should say, these two particular terms are emphasized a lot. Okay, and how I'd like to describe them to students is think about like a family. Okay, so you have a parent and a child. All right, so the parent, okay, that's going to be independent, right? Hopefully they're independent. Okay. Right? They're the ones who are providing the shelter, the food, the clothing for the child who is dependent upon the parent. Okay? So, but in mathematical terms, the independent variable is represented by X and the dependent variable is represented by Y. Okay? So X controls the equation. Whatever you do with X, Y is dependent upon it. Okay? It the answer is going to fluctuate depending what you put in for X. Okay? So that's why X is referred to as the independent, because again, it controls the equation, and Y is the dependent variable. Okay? Another way to think about this is input output. Okay, so sometimes X is referred to as the input. Okay, because we're replacing it or we're putting values in for X. And then Y will be the output. Okay, it is affected by whatever is inputted for X. So another way I like to describe it is like a vending machine, right? So you find out what you want from the vending machine. Maybe it's candy bar, pop, whatever it is, and then you select your item, right? And then you pay. Well, actually, you pay first, then you select your item, okay? And then so that's the input that you're putting in, and then the output is the product. So whether it's the soda pop or the candy bar, whatever you chosen. Okay. So it again, the vending machine describes that input output situation. Okay? All right. So now let's go ahead and try to answer these questions. So the first one says a graph in an atlas shows how a city's average temperature varies in relation to its distance from the equator, which is the independent variable in the relationship. Correct answer. Okay. So again, it says a graph in the atlas shows how a city's average temperature varies in relation to its distance from the equator. Okay. Which is the independent variable in the relationship? Well, it's going to be the distance, right? The distance from the equator. The distance, okay, determines the average. Okay. Okay, let's look at the second one. It says the weight of a package affects the cost to send that package through the mail. Which is the dependent variable? The weight of the package or the cost to mail the package? Okay. So again, the key part here is, what is being affected, the weight or the cost? All right. So which is the dependent variable? Well, that's going to be the cost to mail the package, right? The weight will decide the cost. Okay. The more heavier it is, the more expensive you're gonna have to pay for the the mail, the cost of the mail. Okay. All right, let's look at the last one here. It says a function tells us how to compute the output P when the input C is given. Which is the dependent variable for this function? Okay, great, right? So the dependent variable is the output. We talked about that, right? The output. So output P, okay, so the answer is going to be A here. That's dealing with the dependent. So very good. Okay, so the table below shows the amount of shrimp and the amount of beef bought by each of 7 people. Create a scattered plot for the data. Okay, so this one, you have a table here in the first column is dealing with the amount of shrimp in pounds. And then the second column is the amount of beef in pounds. And all they want us to do is create a scatter plot. Okay, so the first column here is going to represent the X values, and then the second column here is going to represent the Y values. All right, and these here are just going to be coordinates. Okay, so this is going to be like, 211, 5, 6, 7, 9, 8, 4, 11, 13, 12, 12, and 13, 10. Okay, so those are being represented as coordinates, and what we want to do is we want to um, draw an X and Y axis. Okay, and then plot these points. So let's do that. So, okay. So the vertical line is going to be our y-axis. The horizontal line is going to be our x-axis. Okay. And you just have to, make an educated decision, what you're going to go by. Okay. So what's going to be your um, interval or your increments here? I'm going to go by fives. So this is going to be 0. Here's 5. Here's 10. And then here's 15. And then the same thing here, 5, 10, 15. Okay. All right. And I'm just going to plot these. All right. That's what a scatter plot is. Okay. All right. So the first one is 211. So that's about right here. Okay. There's 211. Okay. Then I'm going to do the same thing for the rest. Okay, so I just plotted the rest of these. Okay, so again, the first one is 211. The second one is going to be 5, 6. Third one is 7, 9, so on and so forth. Now, one thing we do need to make sure is we label this correctly. So the x-axis is representing the shrimp, and then the y-axis is representing the beef. Okay, so don't forget that. It says the data points on the scatter plot below show the number of hours worked and the amount of money spent on entertainment last week by each of 25 students. Draw the line of best fit for these data points. Okay. It doesn't have to be the exact line of best fit. Just draw your best approximation. Okay, so this line of best fit, okay? Sometimes that's referred to as the trend line. Trend line, and sometimes it's called the regression line. Okay. In statistics, that's what they call it mostly. Okay. So again, the line of best fit sometimes is called the trend line and sometimes called the regression line. And all you're doing is, you put a ruler over these points and you're trying to find out, okay, which line is going to best represent these points. So for example, you don't want to make a line out here, right? That doesn't make any sense. Or make a line going like this, or a line going like this, or a line going like, you know, going like that. All right, it doesn't make any sense. So what you want to do is, you want to draw your line in between these points, okay? So probably something like something like that. Okay. So let's make sure that you understand that. So this here, this line that I just drew, this is the line of best fit. Okay. This is the line of best fit. And one thing about this is that this is just an estimation. All right. It's just an estimation. All right. So anything that you get from this line here, okay, is an estimation. And a lot of times it's represented by an equation, okay, which we'll talk about in a couple of slides here. But anyway, so this line here is the line of best fit. And these points out here, right, these right here, these are your actual points. The ones that are marked X. These are your actual points, actual data points. Okay, those are actual data points. Okay. All right, so before we answer these questions, let's talk a little bit about slope. Okay, so this is slope. Okay, now remember there are four types of slopes. Okay, you can have this kind of slope, this kind of slope, this kind of slope, and this kind of slope. Of course, they're going to fluctuate in regards to the steepness of the slope, but in general, this is what we have. Okay, so for the first one, what kind of slope is that? Okay, so remember the first one, this is a positive slope. Okay, that's a positive slope. Pointing to the right is positive slope. So if that's positive slope, this one pointing to the left, it's going to be a negative slope. Okay, what about this one here? What's this slope going to be? Well, think about somebody, that's flatline, right? If somebody flatline, that means they have zero heartbeat. So you're going to have zero slope. Okay, right? Somebody that's just flatline. Okay. And then the last one, what about this one? What's this one going to be? Well, that last one is going to be undefined. Okay. Why is it undefined? So remember the slope formula, right? The slope formula is m is equal to y2 minus y1 over x2 minus x1. That's the slope formula, right? And so if say you have 2 points, let's say the points are, I don't know, 2, 5, and 7, 5. Okay. So how do you calculate the slope? Well, remember, we just need to label this. So this will be our x1, y1. This will be our x2, y2. Okay. And then we're just going to um, write down what we have here. So y2, actually, let me take that back because I'm trying to prove a point here. So I flipped the numbers here. Actually, you know what? That's okay. All right. So if we have 2, 5, 7, 5, that's going to give us what? Y2 is 5. Y1 is 5. X2 is 7. And X1 is 2. So 5 minus 5 is 0. And 7 minus 2 is going to give us 5. So 0 divided by 5 is going to give us 0. Okay? We get that kind of graph. Now, let's say we flip this, okay? So let's say we flip this and we had the other way. So let's say now we had 5, 2, and 7, 5. Sorry, 5, 7. So 5, 2, 5, 7. So we're going to do the same thing. We're going to label this x1, y1, x2, y2. Okay. All right. So when I write my slope here, so y2 is 7 minus y1 is 2, x2 is 5, and then x1 is 5. So we get 5 over 0. So remember, we can't divide by 0. Okay, so this one is going to be undefined. All right, and sometimes that's represented by 0 and a slash. Okay, so that's why we will get this kind of graph. Okay, it's undefined because the denominator goes to 0. Okay, so let's go through these questions. Says for these 24 students, so it says the scatter plot shows the time spent texting and the time spent exercising by each of the 24 students last week. Also shown is the line of best fit for the data. Okay, so what do we notice here? So the y-axis is referring to the time spent in exercising in hours. And then the x-axis, the horizontal, is the time spent texting in hours. So notice that as the time spent, and I've been to the gym several times, and I see this a lot. So the time that people spend on their phone texting, the amount of time that exercising goes down. Okay, because they're focused on their phones. Okay, so it's the same thing in the class. That's why I tell students, no, what's the point of coming to class if you're just going to be on your phone? Okay, you're just wasting your time. So um, go do something else. Okay. So, but if you're here, I expect you to do the problems and do the work. Okay. Maximize your time. So, so anyway, so again, the more times these students are spending time on texting, the less time they're going to spend on exercising. Okay. So let's answer these questions. It says for these 24 students, as the time spent texting increases, the time spent exercising tends to what? For B, for these 24 students, there is a blank correlation between time spent texting and time spent exercising. And for C, use the line of best fit. We would predict that a student texting for 5 hours would exercise for approximately what? Okay. Okay. So for the first one here, right? So as the time spent texting increases, as we mentioned, the time spent exercising tends to decrease, right? The second one here, for these 24 students, there is a what kind of correlation? Well, remember, we write down our slopes. It's a negative correlation, right? So this is a negative, it's a negative slope, so it'll be a negative correlation. All right. And the last one, using the line of best fit. So the line of best fit, remember, is the solid line, not the actual data points. We would predict that a student texting for 5 hours. So here's 5 hours. So we just go up, okay? And it looks like they're spending 5 hours, or they have 5 hours for exercising, okay? So the answer here is 5 hours. Okay, so saying if they spent 5 hours of texting, they would approximately spend 5 hours exercising. Says the scatter plot shows the number of hours worked X and the amount of money spent on entertainment Y by each of the 24 students. So the X-axis here is representing the number of hours worked, and the Y-axis here is representing the amount of money spent on entertainment in dollars. Okay, so it looks like the number of hours worked, okay, increases, the amount of spent on entertainment also increases. Okay. Says use the equation of the line of best fit. So remember, that's the black solid line going across, right? The line of best fit. Use this line, and this line of best fit is represented by this equation. So that's what I mentioned. This line here is represented by this equation. Y is equal to 1.87x plus 11.26. Okay? That's represented by this equation. So we're going to be using this equation to answer our questions. Okay, so again, it's giving us the line of best fit. All right, and we need to use this equation, okay, to answer our questions. All right, says, what is the predicted amount of money spent on entertainment for a student who doesn't work any hours? Okay, so remember the x-axis, okay, the x-axis represents the number of hours. So in this case, if they didn't spend any hours working, then we would put 0 in for x. Okay, so we would have A, this is part A, y is equal to 1.87 times 0 plus 11.26. Why do we put 0? Because they didn't do anything, right? It doesn't work any hours, so that's 0 hours. So 1.87 times 0 is 0 plus 11.26 will give us $11.26. Okay. All right, let's look at the second one. It says for an increase of 1 hour in time work, what is the predicted increase in the amount of money spent on entertainment? Well, this is dealing with this slope, okay? For an increase of 1 hour in time work, what is the predicted increase in the amount of money spent? This is your slope, okay? Or sometimes it's called the rate of change. All right. So remember, y is equal to mx plus b. That's our linear equation. M is represented by the slope or the rate of change, okay? And b is representing the y-intercept. All right, or the starting point. That's called the starting point. Okay, so when it's referring to this particular part, it's dealing with the rate, the slope. And we have that. Okay, that's just 187, 1.87. So for B, the answer is just 1.87. It's asking what is the slope? The slope, this is M, right? That's their slope. So that's the rate of change. All right, and then for the last one here, what is the predicted amount of money spent on entertainment for a student who works 8 hours? Right? So we're going to go back to our equation. Y is equal to 1.87x plus 11.26. And all we're doing now is putting 8 hours in for x. So 1.87 times that by 8 hours plus 11.26. And when we do that, we get $26.22. Okay, so this next one is talking about this correlation coefficient. Okay, correlation coefficient. The correlation coefficient is talking about how strong that relationship is between the two things you're trying to compare. Okay, so the correlation coefficient is going to go from -1 to +1. Okay, so as it gets closer to +1, you're going to have a strong correlation, positive correlation between those two items that you are comparing. And if it gets closer to -1, okay, then you have a strong negative relationship between those two things you're comparing. Okay, But as you get closer to zero, that means there's no relation. Okay. So for example, okay, if I look at these here, zero would be figure one, right? The all of this here, they're just scattered everywhere, right? So there's no relationship between these two items you're comparing. Okay. Now let's look at one. This one here is getting close to one, right? It's getting close to one. All right. So that means this is um, a positive relationship. However, if we look at the one over here to the left, this is a stronger positive relationship. Okay, because they're all lined up. Okay. Um, so again, as they're getting closer to kind of this line here, then or the slope is getting to that looks like this, then you have a strong positive relationship. Okay. Now, as they're getting spread out, so this one here, right, this is going to be kind of a weaker relationship in the negative direction. So this is positive, this is positive. This will be a negative one because it's a negative slope. Okay. And so it has um, the correlation coefficient is going to be going towards to -1, but not close to -1 because again, they're a little bit spread out. So maybe it's like 0.75 or 0.65 or something like that. Okay. But anyway, so but this one you'll have a negative relationship between, the two things you're comparing. All right, so I'm gonna go to the previous slide here. All right, if you see a graph that looks like this graph just means it's non-linear, right? So linear, this would be a linear graph, right? It makes a line. Linear means a line. Non-linear means it's not a line. Okay? So it makes something like this. Okay? So when some students ask, well, what about this here? It doesn't do anything. So this is just a scatter. This is just a scattered plot. But again, if you have something that looks like this, it's nonlinear, it's curving. Okay. So that's what they're referring to. Okay, the last one. So this one is talking about whether there is a relationship. Okay. Correlation versus causation. Okay. So correlation does not imply causation. Okay. Correlation does not imply causation. So for example, real quick, let's say Shaquille O'Neal is an NBA basketball player. He's like 7'2". I'm not very tall. So let's say from the age of since we're 1 years old, we drank milk every day, okay, until we turn 18 years old. Can you say milk caused Shaquille O'Neal, this basketball player, to grow to 7'1", 7'2"? Yes or no? Okay. But for me, right, I drank milk every day. Okay. So anyway, can you say that milk caused Shaquille O'Neal to grow that tall? And the answer is no, because I didn't grow to be 7'1" or 7'2". Okay. So there are other factors that um, caused him, okay, to grow. Genetics, right? His parents are tall, things like that. Okay. So that's what this is saying. Correlation does not imply causation. You can't say one thing causes another unless you have a lot of data that refers that, which is hard to do sometimes. Okay. So so let's look at this one quick question. It says, actually I want to go to the second one here. Okay. It says a grocery store collected sales data. It found that when customers buy less bread, they tend to purchase more rice. What can we conclude? This one here is we can say it's going to be the answer to this one is going to be there is a correlation between the amount of bread bought and the amount of rice purchased. However, there may or may not be causation. Further studies would have to be done to determine this. Okay? So when you see something like this in the lab, this is what they're asking for, okay? There is a correlation between them, but there may or may not be a causation. Further studies would need to be done to determine this. Okay. All right. But if you go to the first one here, a researcher measured the shoe size and math ability of a large group of children. She found that having a larger shoe size does not indicate that a child has more or less math ability. What does her analysis show? Well, the answer to this one is going to be the first one. There is no correlation between shoe size and math ability. If that was the case, then all basketball players, right? I went to the Basketball Hall of Fame, and I believe it's in Connecticut, and they had Shaquille O'Neal shoe size there. It was like size 23 or size 27. It's huge, massive. That means he would have to have the highest math ability. I don't know. Okay. But that's what this is saying. But so anyway, there is, you can't say there's a correlation between the shoe size and math ability. All right. Okay, I just want to go over these last couple of problems that I talked about. I just want to make sure that we uh, get these problems correct. So I just want to write down the answers to these. All right, so for that part A again, the answer to that was um, the first one. Okay, there is no correlation. There's no correlation between the shoe size and math ability. For part B, um, we have here. Okay, for part B, there is a correlation between the amount of bread bought and the amount of rice purchased. There may not be causation. Further studies would have to be done to determine this. And then part C is the same thing. There is a correlation between height and serve speed. There may or may not be causation. Further studies would have to be done to determine this. Okay, so those are the answers for this slide. Let's go back to this slide here. All right. So this one we had to number which figure goes with the particular question or statement. So the first one says, which data set appears to show a negative linear relationship between its two variables? The answer to that is 3. For B, which data set appears to show a positive linear relationship between its two variables? The answer to that is 2. Which data set appears to show non-linear relationship between its two variables? The answer to that is 4. And which data set appears to show no relationship between its two variables? The answer to that is 1. Okay. And this last slide here. For which data set does the correlation coefficient R appear to be equal to 1? Okay. So again, we need to identify which figure goes with what. So this one would be number 2. Which data set has apparent negative but not perfect linear relationship between its two variables? The answer to that is number 4. And the last one, which data set indicates the strongest linear relationship between its two variables? The answer to that is 2 as well.